Hey everybody, welcome to today's Getting Started with Kubernetes and Rancher online training. Really happy to have you all on the line today. And while people are joining, I want you to know that this session is being recorded and you will receive the video and the slides after the presentation. We have about 90 minutes scheduled, and we often go long just because we do our best to answer every single question. We have almost 150 people registered today, so I'm expecting a pretty lively class. So let's go ahead and jump in. So our goals for today are to give you a really solid technical introduction to Kubernetes using Rancher. We'll go over Kubernetes concepts and components and architecture, and we will demonstrate that with slides, but we try to do our best to keep the slides to a minimum and to show you how all this works hands-on. So we do have an in-depth demo of Rancher and of Kubernetes. So you can follow along with what exactly is going on. And we try to do our best to be as responsive as possible to what you want to learn. So please ask your questions, ask them early and ask them often. We do our absolute best not to leave until every question is answered. GoToWebinar has a really cool questions feature. So just click on the questions tab and ask your question there. If for whatever reason you want it to be private, just let us know. Otherwise, we'll answer it for everyone for the benefit of the class. We also hope that this is like the beginning of your learning journey. There's just so much to learn and to practice, become masters, in these technologies, and we really need a community and ongoing education to do that. So we have a lot of different classes at different levels offered, pretty much all free. So every Tuesday we put on more advanced training sessions in different aspects of Kubernetes, monitoring, security, and things like that. I'll talk more about that at the end of our session. And then finally, we want to get better as teachers, as presenters, and give you guys what you all really want to know. So we do have a survey at the end. It just takes a couple minutes to fill out. If you're able to, please do so. It really helps us get to know you all and know what you want to learn, so we can come up with new topics and new ways of teaching. As a way of introduction, my name is Matthew Shear, Marketing Manager here at Rancher. I help with these training sessions and the ones on Tuesdays, online meetups. If you need any resource, if you did not receive the slides or the recording, or you're looking for something, please reach out. I'm happy to help. I included my email, so don't hesitate to keep the conversation going. And our presenter on the line is Jason Van Brakel. Jason, are you there?
I am here.
All right. So yeah, Jason will honestly be doing the heavy lifting for this session. I'm really looking forward to his presentation. I'll let him introduce himself a little bit more as we go forward. So a couple of housekeeping items before we dive right in. We hope you come to this training with a basic understanding of containers, so Docker containers. If you don't worry about it. We try to make this training really accessible and to answer any questions you do have. So please ask away about Docker if you do have questions on it as it relates to Kubernetes and Rancher. And we have a ton of resources on our blog and our docs on containers, so you will not miss out if you need to learn more there. And if you want to have your own instance of Rancher going while Jason does his demo, you can get up and running in just a couple minutes. Rancher is totally free. It's open source. Nothing is hidden. No features are hidden from view. You'll get all of Rancher when you download it. So just go to rancher.com, click the deploy button, and it'll bring you to the quick start guide, and you can get up and running in just a couple minutes. So with all that out of the way, I'm going to pass this over to our Director of Community, and he's going to talk more about our Slack and forums and get us going. So Jason, I'm going to make you the presenter.
All right. And then let me share my screen. All right. How's that look?
Awesome. You're good to go.
All right, so you'll notice my slide's slightly different. I'm missing the Slack channel, but if you want to join us today, we're currently live. If you're not on our Slack channel, go to slack.rancher.io and go ahead and sign up for a free account, and you can join us in the online training channel. So we'll be hanging out there as well as questions on the GoToWebinar. If you'd like to reach me after today, with questions, I know we'll be hearing a lot today, so we have a whole lot of other resources available to you. I'm on Twitter. In spite of the terrible new layout, I am on Twitter. So I'm Jason Van Brackle, and most of what I post out here is about DevOps, about Rancher, about Kubernetes, and unfortunately a little bit about the Baltimore Orioles and Baltimore Ravens because I'm originally from the Baltimore area. But by all means, follow me, check it out. In addition, if you go to rancher.com/training, lots of good free resources out there, both previously done and upcoming. And you can even get the videos for that. I also invite you to our YouTube channel, youtube.com/c/rancher. And then a video similar to this is out there, as well as a bunch of other playlists and really, really useful information. Also, I'm launching, not next week, but the week after the Ranchcast. So think, live coding, think interviews with interesting Rancher people and interesting Kubernetes people, but just a live show once a week for me to connect with you. We'll go over problems that I see in the Slack community, questions that come to me from Twitter, all sorts of things. We'll cover that as well. And if you want past Ranchcast episodes, they're available on youtube.com/c/the Ranchcast. The other page there was from our blog yesterday. You can find that, and we'll be broadcasting live to YouTube, to Mixer, and to Twitch, because I know some of y'all's corporate firewalls will block Twitch and Mixer. So with no further ado, let's get started. So let's start with Kubernetes, and specifically on Kubernetes momentum, because Kubernetes is not the only container orchestrator out there. There are lots of them, but Kubernetes has won the market share. It's currently in the front of Mindshare. There was Docker Swarm, and it is Docker Swarm. There is Nomad. There's Mesosphere and DCOS. There are lots of ways to orchestrate containers. But Kubernetes has grown substantially, both in large company support, in market and mindshare, and just in general usage. And many major IT vendors have either added K8s offerings, K8s, Kubernetes, or are in the process of adding K8s offerings. You can see here, there are lots and lots and lots of companies like Google, who started it, Red Hat, Microsoft, and a bunch of independent software developers who work for some of these companies or work for companies like Rancher, who contribute to Kubernetes source code. Kubernetes, again, is just an open source project. But Kubernetes is the brains of the operation. It's much like the kernel in a Linux distribution. It's very quickly becoming the kernel for the cloud. But it's a very, very complicated machine internally, and it comes with a lot of operational challenges that go well above and beyond just day one. How do I get Kubernetes up and running? So all these other things that we have to think about if we're going to operate Kubernetes at scale. And the pace moves very fast. Kubernetes has a quote unquote minor release every 3 months. And we use minor in quotes because new features launch in minor releases. Like in 1.14, the Windows GA support launched, and that in of itself was several years of development before it hit GA. So understand, there is no LTS. It's not like in Ubuntu where you have an LTS that's going to stick around for years and years. There is a minor release every 3 months, and the community only supports the last 3, maybe 4 minor releases. So that means at least once a year, you're going to have to worry about upgrading your Kubernetes cluster. Now, personally, I think you should just automate all the things, and you just create your new Kubernetes cluster every 3 months, every 4 months, every 6 months via all your scripting, and you send all your workloads over there. But that's ideal, and I understand that enterprise software doesn't always work that way. But understand, when you get into Kubernetes, this is what you're getting into, fortunately and unfortunately. And Kubernetes is built on APIs, abstractions. So to really know Kubernetes is not just an operational concern, it's an API concern. Yeah, and to give you an idea what that looks like, if we were to go out to the Kubernetes API, and we can see here, just for 115, yes, that's the link I want. For each one of these APIs, it's its own set of YAML or JSON. So taking a look at a pod, for example, we'll talk about pods later. It has a has a very specific. If it works, let's try 114 to see if 114 will help us out here as far as the example goes. And kubectl example, there we go. So every one of these APIs has a YAML spec with all the things to worry about as far as that individual spec. So knowing Kubernetes is just about running Kubernetes, but knowing how to talk to Kubernetes. And so all of the various clients, Rancher included, know these APIs to talk to that specification. So today we're going to look at Kubernetes 101. We're going to talk about 5 or 6, maybe 7 various concepts of Kubernetes. So pods, what we just talked about shortly, is one of them. So with this list of 5, a couple other things we'll talk about, you can get started hands-on with Kubernetes, orchestrating containers. You're not ready for production. There's a lot more you have to learn, but we have enough to get started. So let's talk about pods. Pod is our smallest atomic unit of deployment and scale. They are co-scheduled, which is just a really fancy name for on the same machine. So pods, these pods can speak to each other over, the containers inside the pod can speak to each other over localhost. The concept can be a little confusing. I like to think of a pod kind of like a VM. Sometimes you think of pods as containers. Yes.
Jason, I'm just going to interrupt you for a second. I think the sharing has frozen, so we're not seeing the current slide you're on. So could you just stop sharing and then reshare?
Let's do it.
Cool. There we go.
How we look? Let me adjust my sharing settings just to make sure it's showing the whole screen. There we go. Full screen.
Awesome. Thank you.
You're welcome. Thanks for the heads up. Yeah, the warning was on the monitor that's like kind of behind me, so I did not see the warning. So good catch. All right.
Teamwork.
So pods, a lot like virtual machines, except not really, because you're not isolated the same way a virtual machine is isolated from the processes. If I do a ps-ef in Linux, I can see all the containers that are running inside of my pods all co-scheduled. So sometimes it's useful to think of it as containers. Sometimes it's useful to think of them as VMs. They are virtualized operating systems, essentially. It's what containers are. They're virtualized operating systems. So inside of my pod, I might have two simple containers here. I have an Nginx and a Redis container. And my application running inside Nginx is talking to my Redis container, one local host, 6372, just to beat the dead horse. That's how pods work. One thing of note. I'm going to, occasionally when you start digging into this stuff deep, you're going to start hearing about things like sidecars and other patterns. They come from, well, not this book specifically, but this is a great book on it because it talks about designing distributed systems and about all of the vocabulary and patterns that go into designing big distributed systems. So it is definitely worth your time to take a look and read this book. It's free. Microsoft has put this out. Brendan Burns helps write Kubernetes with Google. He's now on Microsoft. I forget the actual title, but he runs the AKS stuff and a bunch of stuff around Kubernetes and helped write this book. This is definitely worth your time. So we talked about pods. And each one of these concepts is a separate API. It has one job. So the pod's one job is to hydrate containers to make sure they're up and running. The next abstraction built on top of the pods is a replica set. Replication controllers are still around. They're just older. And you probably won't create these by yourself. You can create these by yourself, but there's probably going to be created by a separate controller. And when I say controller, these controllers are various algorithms within Kubernetes that are the living embodiment of plan, do, check, act. So it's quite literally, I create my API definition for my, API definition for my pod like this, and the And a controller's job is to check, hey, do I have my pod? Yes. Okay, sleep. Do I have my pod? Nope. Go create my pod. And all these controllers kind of work that way. Whether it's deployment, whether it's replication controller, replica set, they all kind of work that way. So replica set, for example, looks a little bit like this in the YAML definition. It looks like it has a combination of a pod spec and a number of replicas. So just abstraction built on abstraction. So again, pod deals with deals with a set of containers. Replica set deals with a set of pods, so desired scale. And they work a little bit like this. So let's say I have 12 of these running in my infrastructure, and I walk through the data center with my cup of coffee, like I have here in my hand now, and I trip and I fall and I spill coffee on a server. Now, that probably isn't going to happen because you shouldn't have coffee in the data center, but bad things happen. Some of us noticed a Cloudflare outage last week or the week before. Azure has had AD and Resource Manager go down. That was a really bad 72 hours for me. S3 has gone out. Things will go bad in your data center and others' data centers. So Replica Set helps us take care of that. As long as there are resources available in the mesh, you'll get your 12. If not, there'll be logs and events and all kinds of stuff yelling at you that you don't have enough resources to create the thing that you just asked for. So now with our first two sets of abstractions, we have the pod, which creates containers. We have the replica set, which is count of pods. Now we have deployments. This is a controller that helps you create and update replica sets, and the end goal being allow you to perform rolling upgrades in your ecosystem. And they work a little bit like this. So again, we have our pod here with our Nginx and our Redis. And let's say we update the container version of Redis. Some bug got fixed, something went bad, and now we fixed it, and we want everything to be good now. So we have V2. So 2 new V2 spin up, 2 V1 spin down, 2 V2 spin up, 2 V1 spin down. These things are customizable. The default is 1 and 1, and it saves like 10 revisions into history. So this has some things we have to think about as engineers, as software developers, as operators, is that I have to deal with this situation where I could have multiple versions of the same API, running in production, and who knows what happens if we don't design around this. I could have split brain, I could have all kinds of interesting issues going on. But we need to design our software and design our APIs to handle this situation until we can guarantee that we're here. And if there's a problem, deployments will also roll back completely, which is really nice thing about deployments. Back to, I think, 10 revisions by default, I think I said earlier. So those first three things were all about deploying applications, into our mesh. This next thing is how we expose them. So we're going to talk about two ways of exposing. I'm going to talk about layer 7 and layer 4. And I'll do my 90 seconds on layer 7 and layer 4 because not everybody knows what layer 7 and layer 4 are. So this goes back to the OSI model. This is what's going to teach in networking classes and comp sci, and when you start studying networking, you learn about the OSI model. And the OSI model is basically how network systems talk to each other. So if I have, we'll grab this one, and we'll just view image so we can make that larger for y'all like me who have bad eyes or wearing glasses. So if there are two separate computer systems, and this could be this works on the internet, it works inside your private network. So traffic logically goes across the layer. So when I'm talking HTTP, HTTPS, I'm here on application layer 7. My web browser is talking to a web server over HTTPS. It's my application layer. Now, physically, it goes down one set on one machine, across the physical link, and back up. So down here at layer 1, we have essentially how data gets turned into electrons. It gets sent over the wire. In the case of this 802.11 type of stuff. So how Wi-Fi works and how your Ethernet cables work. That's your physical layer. Up here at layer 7, we have HTTP, HTTPS, FTP, all of our application layer protocols. In the middle, we have network layer and transport layer. So network layer is how we address things. So think, IP. And then we have our transport layer, I think TCP and UDP. So whether we guarantee delivery of packets or not. So this is where we get the terms like TCP IP and UDP IP come right in here. IPX, SPX type of stuff, all in here. If you're back from those Novell days. So when I say I'm talking about layer 7, I'm talking about, actual, URLs, routes, hosts, that type of thing. When I'm talking about layer 4, I'm talking about TCP IP. So, IP port combinations, for example. So services, this is how we start exposing over layer 4. That's our TCP IP. Inside, you have a set of containers inside of your Kubernetes cluster, running kubedns or core DNS, depending on the age, and that is actually providing DNS entry for each of the pods. So something you actually have to think about is, Something to think about is there are 3 separate subnets going on in Kubernetes. Your host subnet, which is all of the nodes that are running Kubernetes. You have your services subnet, or your cluster sitter, and that's all of these layer 4 services. And you have your pod subnet, and each pod has its own IP, which means those subnets are finite, which means those IPs are a resource that has to be controlled. Something to think about as you move on in protecting resources in Kubernetes. And there are essentially 5 different types of services. And you have external name, which is like a Class A DNS flip. We go from an internal DNS address inside of Kubernetes to some of the outside world. Really useful for external databases like your SQL servers and your Oracles, for example. We have our host port. I'm not going to dive into host port today. If you really need host port, you go look up the documentation on that and figure out how that works. And the other 3 here are node port, cluster IP, and load balancer. So cluster IP is quite simple. This is services that allow that expose layer 4 inside of the cluster. So one service can talk to another service via its internal DNS or via its internal IP address. This is how we have service discovery inside of the cluster. Node port. Actually, let's talk about node ports. So node port, we have our client, and our node port is every worker machine in our cluster listing on the same port, whether there are pods on the machine or not. So what's happening here is, let's say I hit this machine, for example, and this machine, because of a process called kubeproxy, will have a bunch of IP tables rules changed that allow all the routing to make sure that it gets over here. Actually, there are a number of processes that are running in Kubernetes. Let's talk a little bit about what Kubernetes is physically speaking. There's a great image on the page. It's called Concepts Underlying the Cloud Control Manager. This is one of the better images on how Kubernetes is put together. So we're going to view this image really large so you all can see it. So we have 3 node types. We have our etcd node, which is our high-speed key value store, our high-speed key value store slash database. This could be in the Kubernetes master, or this can be standalone. Either way, it's just fine. Then you have your Kubernetes master itself, and this is the brains of Kubernetes. So, all the various processes and sub-processes for Kubernetes that control how Kubernetes works are happening here. And inside of here, you can see we have the kube controller manager, which its job is to make sure all those controllers get created and are maintained, like our replica sets, our deployments. For example, our API server is exactly what it sounds like. It's a REST API, and everything talks to it. It is the only thing that gets to talk to the storage medium of Kubernetes. The kube scheduler schedules your pods throughout the system, and it uses all the things it knows about to figure out where things go. And then over here we have our Kubernetes minion nodes, our workers where your stuff lives, and it has 2 processes, kubelet and kubeproxy. And kubelet's job is to make sure containers are created, and kubeproxy is a load balancer that is also helping rewrite all those IP table rules so that your services work, which is its job, to make sure those IP tables rules get work so that when you hit this IP port combination, it goes to the right set of pods. Load balancer is a special case. So a load balancer actually has node ports associated with it, but the implementation of the load balancer itself, so once it gets past here, it looks like this. except instead of, instead of going from straight off the client, it's going from the load balancer to the clients. But that load balancer is implemented differently by each of the cloud providers, and it actually requires that this little thing here called the cloud connector is configured properly. So when you start up Kubernetes, you're starting up also the cloud controller manager for the cluster if it's going to talk to a cloud provider, and it does so through this cloud connector. And that cloud connector's implementation will vary from cloud to cloud. In Azure, it's a service principal. In AWS, it can be an IAM role or a client key secret key. In GCP or GKE, it's the JSON service account representation. So this will vary from cloud to cloud. But if I don't turn this on and ask for a load balancer, I'm never going to get one. It's just going to say pending. Because things aren't ever actually failing. All those controllers, all those control loops will keep trying until everything is turned on properly. So you can see the get an IP address will say pending, 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 pending forever. So that's why you expect to watch your logs. So now config maps. So we dealt with all of our controllers and all of our ways of pushing things into my cloud. Then I dealt with my way of exposing it over layer 4, my services. And now this is the separation. The config map is the separation of configuration from binary. This actually fits really well into a type of software development called 12-factor development. If you go to 12factor.net, you can go read through the 12 factors. This is actually a great way for building web apps or SaaS apps, or really microservices architecture fits really well into this. This is why I bring it up. So this is also worth your time. But one of the concepts is we separate our configuration from our binary. In this case, our binary is our container. So when we build our container, we build it once. It goes all the way through our CI/CD system, all the way through our unit testing, through our integration testing, through our perf testing, through our security testing, all the way through to production. The same built container, not rebuilding the container over and over again. And the difference between how it behaves at runtime will depend on your configuration or your config map. So there are two types of ways to configure values inside of the container. They both behave the same way inside of the container. They can either be stored as files in the container or as environment variables in the container. There are config maps and there are secrets. And the only difference is base 64 encoding. And if you know anything about encoding, you're going, wait a minute, base 64 encoding is really easy to reverse. How is that secret? That's a great question. So secrets are not all that secret, but there are ways of encrypting them and making sure they are more secret. And I would invite you to watch a video from FOSDEM 2019 in your free time. And it is base 64 is not encryption. And it goes about, basically the way of doing Kubernetes secrets properly. We're actually considering, integrating this process into Rancher as well to make it more secure as far as encrypting things at rest go. The problem is that this wasn't even, the feature wasn't even released till, 1.7. And then 1.10 allowed for app layer encryption and KMS. And it really was like 1.13, 1.14 where it really started coming together. And the presenter here, Seth, actually used a term I love called encryption. So secrets are not encryption, they're encryption. So go, make sure that your secrets are encrypted properly. Way deeper than what we're going to talk about today. Something we'll talk about in the Ranchcast this summer and fall. So config maps, just to beat the dead horse, same binary throughout, slightly different values. Now these keys will either be environment variables in your container or files stored in the container. We'll look at that later. Or your secrets. So we've dealt with all of our various controllers structured our pods so that our containers end up in our mesh. We dealt with our services that we can expose them over layer 4. And we've dealt with our configuration via config maps and secrets. The next thing we're talking about is ingress. So this is layer 7. So layer 4 was that TCP/IP, UDP/IP layer. Ingress is layer 7. This is our path host routing. So this is where we do our layer 7 to layer 4 flip. So our traffic hits our front end load balancer. That front end load balancer then goes and talks to Kubernetes workers. But we don't know which service to talk to inside of Kubernetes. This is what ingress is for. So this is implemented by a load balancer called an ingress controller. And the Nginx ships with Rancher, but there's nothing to stop you from using AWS ELB or AJ Proxy or Traffic. There are lots and lots of them that do this. And it works a little bit like this: is you have your path-based routing or your host-based routing. Then it hits the ingress controller. Like I said, it could be Nginx, it could be Traffic, and it goes to your backend layer 4 service, and then that goes to your pods. That should look really familiar by now. But that's its only job. And it is a beta resource, but it is the only resource that does the layer 7 to layer 4 flip. There are other ways of going about it as you dive into Kubernetes, things like Istio, things like Contour that will handle the layer, Linkerd that will handle this differently and better and allow you to route traffic differently. So know that we're just at the top layer. And from an API standpoint, this too also has its YAML. So when I talk about the layer 7 to layer 4 flip, I just have to find it real quick because I don't remember exactly where it is here. It's under service APIs. And I don't have a kubectl example of this. But it's, the ingress spec is quite literally which ingress backend, which is the name of the service. So you don't trip over this like I did when I first started playing around with ingresses. The ingress and the backend service that it talks to, this ingress spec, and this is the service that it talks about, this backend, need to live in the same namespace. So we've been talking about namespaces. Namespaces are like virtual clusters within a cluster. It's just a separator for resources inside of Kubernetes. They can have resource quotas attached to them and things of that nature. But understand that as you dive into this, you start understanding namespaces. The ingress spec, the ingress controller, the ingress, and the service need to be in the same namespace, or things go badly. So we're going to talk Rancher in a few minutes via demo versus doing it by more slides, because slides bore me. Matthew, do we have any questions so far?
We don't actually. So yeah, you're good. And just a reminder to everybody, if you have questions, please let us know and we'll pause and answer them.
Awesome. And I'm just checking nothing on the Slack channel so far. So yeah, no questions so far. So let's do a little Rancher 20101, and we'll walk through these in my own little way. And I usually use a prod cluster for this, but it was not, my scripts were not behaving in Azure. So I'm actually, it's still being taken down. Something's going wrong there. I'll figure it out later. Fortunately, I always have a backup plan. And yes, there is potential security risk because I'm using self-signed certs, which is kind of the default. So I set this cluster seconds before we got started today, and hopefully I can remember what I put for my admin password. So otherwise, I'd be starting over. But this specific cluster here is absolutely consistent with what you'd see if you went to our docs and you went to our Rancher 2X read the docs, and then you went down to installation, and then you hit the single. Let's try it again. Single node installation, and then I'm using, I think it's option A, default self-signed cert. That's exactly how I started it up. I started it up a lot like this, except I didn't use the -D, so I have a terminal window off to my left that is just showing my live container running. So this is running inside of a Docker container. It is really this quick and easy to get started with Rancher. So no way is this prod ready. We want to do some other things for prod, like bring our own certs or use the Let's Encrypt cert. But I was having issues with my Let's Encrypt certs, so I decided to leave it alone for now. So adding clusters, and we'll add one right now. So there are essentially 4 different ways to add a cluster. We can use one of the major Kubernetes providers. We can grab nodes from an infrastructure provider and then install Kubernetes via RKE, which is Rancher Kubernetes Engine. We can import existing clusters that were created elsewhere. You can even import OpenShift and Mesosphere clusters. I've actually done that. Or you have custom, and custom is your bare metal option. So if I were to do a custom cluster, I don't think I have any nodes hanging around I could do this with, but I'll at least show you how it works. We already have RBAC enabled with different roles. We have some default things that were created. We'll walk through in a moment. We have options, so we support the 3 latest versions, and usually we'll have a 4th there for whatever was just released. And experimental means we're like 90% sure it would work, but we have really robust testing processes before we turn the experimental off. So feel free to check out 115, One Rancher. I've done it for a couple of ones already. I've had no problems with it. It's just, it's considered experimental, not part of our, like, people who pay for, Rancher support. We don't officially support this under our SLAs, for example. And then cloud provider, this is that cloud controller, the cloud controller manager we're talking about. If I hit none, it doesn't even turn the sub-process on. If I actually select one, I have to go through and configure it so I can talk to the cloud properly. In this case, I'm just going to turn this off. And let's grab one of these cloud providers here. I'm going to grab DigitalOcean because I know that will load nice and fast. And let's see. I need a key. Question is, how do I get that key without exposing it to you? So I forgot that I don't have that key on this machine. But fortunately, I have two monitors, and I'll grab that key real quick on my other monitor. So I'm going to go SSH into that other machine. And I'm in. Now I just need to go grab that key. Go into my special secret keys area and grab my DigitalOcean key. So let's create my DigitalOcean cluster. And I need a node template. So a node template is exactly what it sounds like. It's a template. Is a template that defines a type of IaaS, a type of node, based on the IaaS provider, what the IaaS provider offers through Docker machine. I'm going to put in my token here, so I have actual access, and my creds work because it did check my creds. And so now we're going to create essentially a droplet type in DigitalOcean. New York 3 is fine. Ubuntu 16 is fine. Let's give it a little more beef in case I want to turn on some extra features. Yeah, let's do that. Root is fine. And we're just going to call this NY3 so that I know what it is later. Hopefully we have enough space for DigitalOcean account, because all field engineering shares this. So that tells me what that is for later. And we're going to create that. And I'm just going to create a single node cluster. Actually, you know what? I don't want a single node because I do want to turn on some monitoring stuff. I'm going to need a couple more nodes for that. So I need my etcd, my control plane, and my worker. Etcd, control plane, worker, and etcd must have a quorum, and so to avoid things like split-related, so you need an odd number, 1, 3, or 5. The old joke is etcd has to have an odd number because it can't even. I know, terrible joke. So control plane, if you want HA, have more than one, please. And the workers just are going to do all of our stuff. Let's create 2 of those, and we'll let that start up. Project network isolation, this actually uses the Kubernetes network policy APIs to make sure that projects can't talk to each other. This is poor man's multi-tenancy. And we support 4 of the more popular network providers. Remember, Canal is no longer an actual project. It is just an installation methodology where we have Calico doing our network policy API and Flannel doing high-speed software-defined networking. And it actually works really well. So let's actually use that. If we want to do Windows, for example, we'd have to also use Flannel because there's a version of Flannel for Windows, but nothing else so far. So 114, and we're good to go. Now I can't do Windows here because I'm not using the version that has experimental Windows support. And then I can actually do private registries if I want to be air-gapped. I have some advanced options around my ingress controllers, my metric server, pod security policies, things of that nature. And then authorized cluster endpoint. This is how we make sure you can still hit your Kubernetes cluster in case Rancher goes down because of how auth works. So I'm going to go ahead and start these up and hit create. So what is happening now? And I can see it on my other Linux box where I have this Docker thing running. What's happening now is Docker machine, which is a separate open source project. We're using Docker machine to spin up IaaS out in DigitalOcean. Once each of those nodes are up, SSH in, install Docker. Once Docker is up, we'll use the Hyperkube container. Now, Hyperkube is an upstream open source container image that has all of the binaries for Kubernetes inside of a single container. So we pass in the things we need. This makes it super easy to spin up our various types of nodes. And we can even see, I can't pull that over a separate machine, but right now I can see Docker being installed on these nodes. And this will take a couple of minutes. While we're doing that, we'll also do a single node cluster out in, let's see, what do I need for Azure? I probably need a service principal for that. I don't think I have a cloud credential on this machine I could use. So let's just skip that. Maybe we'll just do another DigitalOcean one and hope I don't run out of space. So I want to do a single node cluster, for example. I could hit my DigitalOcean here. Actually, I think I do have an EC2 key on here. So if I grab this template, no, this is not the one I wanted. I used to keep, I don't have those credentials out here. I used to keep the Amazon key easily accessible on this machine, but I think I cleared this machine a while back and forgot to do that. So let's just go ahead and create a separate DigitalOcean single node while we're at it. So just to show how we create a single node. Let's go ahead, instead of 114, let's go ahead and install 115 on this. And we'll do JV single and give it one of each role. And go ahead and create. And this, much like that other, this is the process going. We can already see Docker image. We can see we're deploying my Hypercube container. So this is already provisioning our Kubernetes cluster. We have another one going. I could add clusters, as these are going. But let's talk about all the Ranchery things while these are provisioning. So we have our cluster level, which we've been looking at so far. Applications. This is multi-cluster apps. So I could define a multi-cluster app right now, and it will deploy once this thing is done. So let's go launch a multi-cluster application. Let's grab something nice and small like Redis. Now what we're looking here is the catalog. So catalog is an abstraction on top of Helm. So Helm is package manager for Kubernetes. Think ugly YAML with uglier fill in the blanks, but it is the best thing we have right now as far as doing application management in Kubernetes. And there are different package software for having your own Helm chart repositories, like Chart Museum. I think Docker has their own. There's a couple of them out there. Commercial ones like Artifactory, for example. So I'm just going to grab Helm or grab Redis right in here, and we have our own one called Library. And this is the things that we guarantee to work. And if they don't work when we get into a new version, we fix them. But there's also Helm. There's also Helm Stable and Helm Incubator, which are community ones that I don't have turned on right now. Otherwise, I would have extra Redises. And then this scans the Helm chart to build this nice, pretty UI, so I can fill in the various blanks I need for this to work. But we're going to call this Redis multi-cluster. And we're going to target a few projects inside of clusters that aren't even ready yet, which is kind of cool. So we're going to grab the default project in each of these clusters. And we have update strategies and things we can do about this. Let's just set this. We're going to not do cluster topology. I want the smallest thing I can install right now. False, false, false. Just because we're just showing it in install. And if you want to see what Helm looks like, I can drop the preview down and see the actual Helm Helm pieces. Like, so here's our secrets. Those things that are crafted, not encrypted. So here's a secret YAML with ugly fill in the blanks. And it even does some if else based on values that come in. So there are values that you have to define. There are values from the template. There are things from the Helm chart info itself. So I can go to my values here. These are things that we can fill in, various defaults. But then we'll just launch this. Now, there are things that, somebody who knows Helm already would say, but what about Tiller? Because Tiller can be really insecure, because the way most people install Tiller when they're not paying attention is to make Tiller be a default admin. Well, this is one of the, we fork very little. We use a lot of upstream stuff. We did fork Tiller because we have Tiller. When Tiller comes up with your RBAC, the user who requests the installs RBAC. And if they don't have the permissions to install, the install doesn't work. So we actually, make sure it's more secure than the default install. And if I go back to clusters here, oh look, I have one active cluster, and I wonder if this has its install done yet. It's a good question. Worker 2, nope, workers are not active yet. Workers have to be active for stuff to be installed. The workers have not come up yet. And the workers are the last thing that come up. They take so long to come up sometimes that I think they're broken, and it's really, I just used a slow machine, and it was taking its good old time. So we're going to let it continue to take its good old time. But once it's ready, I'll have I'll have something installed as the default. Oh, look at that, and it's already done. My multi-cluster app, well, it's sort of done. It's half done. It has a definition. It hasn't been installed yet. And the cluster here is not ready yet. And it's going to tell us the cluster is not ready yet. But once it's ready, it will do the install there as well. So we can, at the global level, we can see our multi-cluster apps. We have the ability, and you can see once it's installed, we get green. We have our users right now. I just have a local database full of users. I can add other users here, and they would get local usernames and passwords. Settings. I'm only coming here to show you a couple things. One, if you're using the IaaS provider, this is how we're going about installing Docker. These shell scripts are great because they'll detect operating system and try to do it the best way possible. You can add your own in here. Next thing, telemetry. Please opt in. It's anonymous, I promise. I've actually seen the data, the telemetry data that comes in. I look at telemetry data because I just like to see what's going wrong. So just good thing to know. Hey, you have telemetry here, and then server URL. Two really important things about the server URL. One, it cannot change. Well, it can change, but if it were, I might have just lost my cluster. I just saw some major failures. We'll find out in a second. So if I go here and hit edit and change this, bad things happen. And then, the second thing, it needs to be accessible by all the clusters that are going to be managed by Rancher. Let's see, did we kill it? Oh no, it's still alive. Just my Docker. I think my Docker setup over my machine died. Yeah, I've got all kinds of weird errors streaming out of Docker right now, but the server is still running, so we're just going to trust that it's there. So security. As somebody who did Kubernetes by hand before I found out about Rancher, and then I joined Rancher, this was my hallelujah feature. This just brought tears to my eyes. Not literally, but metaphorical tears to my eyes, because the amount of time and energy and life energy that went into handling RBAC in multiple clusters was enough to make me lose part of my sanity. So we build in a number of what we think are sane defaults for a global cluster and projects. For example, we have this idea of cluster owner, for example. And cluster owner is too small. Let's go cluster member. All of these APIs are a combination of Kubernetes APIs and Rancher APIs. And you might ask, hey, how do Rancher APIs fit into this? Well, all of the Rancher APIs that we talk about today are implemented as custom resource definitions. So custom resource definition is the way of extending the Kubernetes API. So we're adding our API to the Kubernetes API so that our APIs are treated as if they were Kubernetes APIs. That's just a really fancy name of way of saying, hey, we've had APIs to Kubernetes. Just like your CLI plugins do, just like Istio does, just like everybody else does who wants to be native to Kubernetes. But that's why we can also protect them with Kubernetes RBAC. So pod security policies. I'll do a whole hour on pod security policies at some point on the Ranchcast. It's really something we should talk about, and we should go into detail on. Just know that this is what protects your hosts from your pods. So the combination of network policy plus pod security policies, like if you've got a bad pod, like a bad version with a CVE already in it that you don't know about, or a 0-day or something like that, having proper network policies set and having proper pod security policy set go a long way to preventing disaster from happening, even if the container itself gets compromised. And resource quotas, heavy resource quotas. And then authentication. This is another one of those awesome features because I have set this kind of thing up by hand using Dex. Dex is pretty cool. Dex is not this cool. So we can actually authenticate our Rancher server and every cluster we create against one of these options here. So Active Directory, Azure AD, GitHub, in our various flavors of SAML and LDAP. And the dirty little secret here is, and it's not so secret because I say it every time I do one of these, is this SAML is actually pretty vanilla SAML. So back before we had the Okta button here, one of our clients figured out how to get Okta working through the ADFS SAML. So if if yours is not mentioned here, it might fit in through here or here or here. So keep that in mind. Tools. So I mentioned Docker Machine earlier. We have Docker Machine node drivers. We just turn on to the ones that most of our clients are using or will ask for. But let's say if I wanted to use Linode. Linode's an awesome company. They have an office in the Philadelphia area where I live now. And I want to use Linode for my nodes. They have really inexpensive Linux machines. But I wanted to use those as a way of creating clusters. I could go in here and now go to my clusters and add a cluster and now have a Linode icon. And this would use the Linode Docker machine driver. The way we talk to Kubernetes providers is through a Container Engine plugin. Container Engine is our own open source project for how to talk to Kubernetes providers like AKS, EKS, and GKE. But we have a few other ones that we have turned on. Let's say Highway CCE, for example. Let's activate that Container Engine. And now if I go back to clusters, it's downloading something. I don't know how long that will take to download. But once it's done, if I go into global and I go to add cluster, I will have them as an option as well. So we've gone through the global level. One more thing. If we want to talk, up there it goes. If we want to talk to the Rancher API directly, either through curl or through the Rancher CLI, we need an API key. So if I create a key here and I say no scope, it means scope to every cluster. If I give it a specific scope, it is scope to that cluster. Useful for making sure that you have proper scoping for your automation. And then expiring, never. Well, you get the idea. Probably probably a little too tedious, but useful for one-offs. A little less tedious, but would still have to rotate every 30 days. But hey, highly secure environment, things of that nature, and this is pretty common. And if we create one, we get the access key, secret key, and bearer token, which is just a combination of the access key and secret key. You see this once, so make sure you save it if you want to talk to the API. And since I showed all of that to you, I'm just going to delete that right now in case you all get any ideas. And then our cloud credentials are stored here, like my DigitalOcean creds. My node templates are stored here, like the one I created for DigitalOcean. So moving on. Before I move on to cluster, do we have any questions so far?
We do.
All right.
Okay, let's see. Okay, this is from Renee. What is the best way to spin up a cluster in an offline environment when using the method you just showed us about?
All right. So we're going to say completely air-gapped. If I go out to docs, so I have my docs right here, and I go to air-gapped install. So we have how to do both highly available air-gapped install and single node. But the gist of it is that I have to have my own private image registry, and I have to load all of the various, no, not my host. I need to prepare my registry with all the images that I need. So it'll give you a list of Rancher images that you have to load into your registry, and we have a script to help you load them. So that way, when you're air-gapped inside of your private infrastructure, you can do that. And then so once you have Rancher installed, and then you have to actually create a cluster, you go in here and you add a cluster and you use the custom cluster. So part of those images you'd be loading are things like etcd and Hypercube and all the other tools like the Nginx ingress controller and metric server and all those. And you use custom. And then once you have a custom, here if I say custom and I hit next, then for every node type, I'm going to execute this Docker run command on each of those node types, and they're going to then phone home back into Rancher server, and then take on these roles. And then then you can also make sure that you set like public IP and private IP for them. This is useful because if we have multiple NICs, we can take advantage of the fact that all the internal Kubernetes traffic can happen over the internal NIC, and all the stuff that has to go public can be public. This is also important on things like IBM Cloud Private, for example. If you're on IBM Cloud, you don't get charged for private traffic, but you get charged for public traffic. So you could blow out your free tier pretty quickly if all of your Kubernetes data is going over public. Then you could override the node name, add node labels, things of that nature. And if I were to adjust a couple of these, one, and then and my name. And you can see here now, it's actually changed the arguments that get sent in to the Rancher or agent command that will then spin up all the Kubernetes bits. But you could actually create, I've done automation right here. If you want to see some examples of automation with this, if you go out to my GitHub, and as I play around with stuff, I keep repositories around, like my Terraform modules. Let's see, let's go with, Rancher. This one is the one I tried earlier and didn't work. And I think it was an Azure issue and not a script issue because I've been using this forever. But essentially what this does, just use custom layout. This one does not use custom layout. I have one around this custom layout. But this actually go through, terraform up the nodes on Azure, install Rancher via Helm. And then, I've got one. It's not this one. I do have one around that will actually spin up custom nodes and then use the custom install. Which one is that? I bet it's just Linux Windows hybrid. Yeah, because I did it for the window. I did it for an episode of the Ranchcast. So this one will actually do. It's in the provisioner. In the remote provisioner, it will actually do. It'll grab the cluster registration and execute that. So, which is basically the same thing. As doing this in automation. And then that'll sit around and wait for etcd and control plane to run. I'm just going to delete it because we don't need that for today. What are the questions we have?
Awesome. Okay, this is from Sergio, who asks, how do you connect to an existing Kubernetes cluster that's in AWS?
All right, so I can go to add cluster and go to import. I would say imported. And when I create that, that will give me a YAML command. So in my case, I'm using self-signed certs, or I may not have a full cert chain that's understood by my cluster. I would run this YAML. Otherwise, I would run the fully protected YAML. Something to note, though, the cluster that runs this has to be a cluster admin. There's some special things we need to do. GKE by default does not create a cluster admin for you. If you want this is kind of like sudo for GKE. Let's see, I created this first. We did this thing called the Lighthouse Roadshow last year. And I created scripts for that because we did work with Google on this, and I had to make sure that I can import the GKE cluster quickly and easily. So it essentially creates the cluster admin. You put your Rancher import command here, and then it removes the cluster admin because I didn't want to keep the cluster admin sticking around. So this is kind of, like I said, this is poor man's sudo for GKE, specifically around importing Rancher clusters. Good question. What's next?
Okay, awesome. All right, this is from Ron, who asks, for supportability from Rancher, should we deploy our clusters via the Rancher wizards? In other words, what is paid support?
Paid support, okay. So I would invite, if you want to know a whole lot more about paid support, if you want to hit our field engineering and sales team really quickly, just go up to the support link and fill out let's see, what does it have? Questions. Yeah, request pricing, if you want to see more about that. Essentially what it entails is we have what we cover is covered by our terms of service, which I believe is on our website. Cool that being open source is we're really, really open. Yeah, so we have an end user license agreement, support level, definition around that, and go check that out. It's rancher.com/support-maintenance-terms to understand what our support matrix looks like, how all that works. And if you want, if you want to talk to somebody around pricing, hit the pricing request. That'll get an email sent out to our sales and field staff. Next question.
Awesome. Here's from Edgar's, who says, What happens to old unused images pulled to servers? For example, I use Maria. Oh, sorry, there's a train in the background. Hopefully that's not too annoying. Open office here. Okay, he says, for example, I use MariaDB 10.4.5, but then migrate all my deployments to MariaDB 10.4.6. Does
Okay.
MariaDB 10.4.5 get deleted from the node somehow?
So Kubernetes has its own concept of garbage collection. This is specific to Kubernetes and not just Rancher as well. So there are things that you can set when you set up your Rancher server around that. So definitely, that would be something to check out in your Kubernetes documentation. And then if you were to set up, now all the providers handle it their own way. They set up their own bells and whistles. If you're using an RKE style system, like this one, I can go into edit here. And if I do a view as, or as view as YAML, this is actually an RKE configuration file under the covers. So we can send in custom settings to the Kube API server, kubelet, kubeproxy, etcd, that can set all those custom settings that you want to set in Kubernetes for your specific use case. So check out your Kubernetes documentation on how it does its own garbage collection, and then set the appropriate flags in here. Next question.
Okay, great. This is from Jared, who actually asked us a while ago, and it's about a Kubernetes concept. It says, can you clarify the difference between load balancer and ingress?
Yes, I absolutely can. So load balancer in this case is a layer 4 load balancer. It is, let's go back to our slide for example for a second. So our load balancer in this case, this is a layer 4 load balancer. So it'll have a public IP address listening probably over 80 and 443, or any other, you can give it other ports. That will in turn then forward to internal services, so other things listening on all the worker nodes at a specific port, specific to that application. So that's your load balancer type from Kubernetes. Your ingress, or this thing, is a rule that says for this route, or this port, or this host path combination, send to this backend service by its name. So each one of these has a name, and each one of these defines a route that goes from here to that name. That's really the differentiation. So this is a rule inside of Kubernetes, for example, whereas this is actually a cloud construct. I wish my prod server would have come up. I'd show that off. Next question.
Okay, great. Okay, the next one is from Chetan, who asks, how do you add a command while creating a cluster?
Add a command while creating a cluster. So if you were to do that RKE style, if I were to go here and edit again, RKE has the concept what's called an add-on. So add-ons allow you to add arbitrary containers and other commands. I don't think we have does the add-on show up here? It is part of the spec. If you check the RKE spec out, it does add-on jobs as well that can run things against it from within Kubernetes. If you want to run other things, like how you can do it during the Docker provisioning stage from your settings menu, I can just change how Docker is deployed so that when Docker gets installed, other things happen as well on the server if it's server related. That's how I detect that problem.
Okay, great. All right, quite a few more questions. Do you want to keep going through the demo, Jason, or do you want to keep tackling these questions first?
Let's walk through the next section, and I'll let Doug give you some time to curate some questions. And cool. They may be cluster related. So we've gone from global, and we've dropped into the cluster level. So now we're looking at a specific cluster. So you see here, I've got my cluster. I can launch kubectl or kubecontrol or kubectl, whatever you want to call it. I don't care. It has command line completion. So if I hit tab here, I get all my different types, both my my CRDs, my Rancher-oriented things and my actual Kubernetes-related things. So I have kubectl get all, and since I am the default admin, I can see everything. I can see everything running on this cluster. This cluster was created in DigitalOcean on my behalf. If you're like me and you like your own Kubernetes tools, you can grab the kubeconfig file. And you can see here we have our front door, which is the Rancher itself, and we have our back door, which is through the cluster itself. So, Rancher is proxying all the auths so that all of our username, passwords, and RBAC work properly. If Rancher were to go down, we don't have the ability to do that. So we keep we keep some information on the child clusters so that you can still get to them in the case Rancher goes down, so that you can do all your disaster recovery things that are important to you. Or if you want to use special tools like I like kube PS1, for example, which actually has Kubernetes prompt for Bash and CSH, so you know which cluster you're in. And the other one is the tool I like having is kube. Actually, he's using that tool during the demo. It's kubeNS and kubectl. So these are both very much worth your time, kubeNS and kubectl. So for changing Kubernetes context, namespaces on the fly. And then kubepс1 just tells you which context and namespace you're in as you're going. And we can see all of our reservations around here. Let's go ahead and enable monitoring. So when I enable monitoring, what is happening is I'm installing I'm turning on the Rancher monitoring API, but I'm also turning on Prometheus and Grafana because the Rancher monitoring API is pulling for Prometheus just as Grafana does. So we're going to enable monitoring. Now, make sure you visit your docs so that you have enough resources to run this. This is why I used a little bit of a heavy-duty server for this demo, and why I didn't enable monitoring on my single node cluster, because I would destroy this single node cluster with the reservation monitoring. And if we turn on this, we go back to our cluster level, very, very quickly, you will see our reservations just jump up as the monitoring API comes up. And so we can see information about our nodes. Now, because this is an IaaS provider, I can spin up more nodes for more, more capacity on the fly in DigitalOcean, as long as I have capacity in DigitalOcean. You'll notice that my control plane and my etcd are unschedulable because they are tainted. In Kubernetes, there's a concept of taints and tolerances. So the only thing that can be installed here are things that have a tolerance that matches the unschedulable taint. So the monitoring API stuff will actually end up here as well, because it will have a tolerance to match that unschedulable taint, so that we can get metrics from Prometheus about those nodes as well, because there are important things we want to know on those nodes. We can coordinate and drain nodes. So if I wanted to take this node out of rotation, for example, I could coordinate off and drain it. I can also do it here as well. So coordinating means, hey, keep everything in there as it is, but don't let anything more on there. Drain says, let's get everything that's on there off of it. And even at the cluster level, if I go back to my cluster, I can do really cool things like rotate certificates, which if anybody has done by hand certificate rotation of all the Kubernetes bits, knows just how valuable that is to be able to do it in a button push. And then constantly, we have snapshots being created of etcd. So the etcd database is being constantly snapshotted. The one I created is there, as well as one that was created earlier. And I can restore it from that snapshot. Once the monitoring API comes up, we start getting really useful data about the cluster itself, about etcd, if we can see it. If you're on a cloud-provided Kubernetes, you won't be able to see that, and various metrics once we start getting data about them. We'll switch that to 5 minutes because we'll actually have some data there. And then we also get Grafana dashboards for all this stuff, both at the cluster level and even the workload level. So every pod now will get Grafana dashboards about them as far as their network I/O, their CPU and memory use. And if I turn on persistence, I can modify these dashboards and save them and reuse them and share them and all kinds of stuff. But these are just default ones we create to make your life just a little bit easier. So if we look at the cluster itself, for example, we see lots of information about the cluster. Not a whole lot of information because we only we get the last 30 minutes here, and we only have like 2 minutes worth of data. But we already have some data about what's running because Prometheus works just that quickly. And then once the monitor API comes up, we also get more information from Prometheus, like the actual amount used versus the reservation, which is very helpful. We already talked about nodes. Storage, I'm not going to dive into storage today. Storage is a really big subject. Something else I'll touch on the Ranchcast at some point. But I did do our Rancher meetup talking about storage back in September, and it's actually really useful for my storage API scenarios. If you want to know about Kubernetes storage APIs, go to our YouTube page. If you go to uploads, which is everything, we did one back in September that talked specifically about the storage APIs in the same way I talked about like ingresses and stuff like that. It's a really basic training. Here it is, yeah. 2018 meetup, understanding storage options for Kubernetes. And we also did, now we're on Longhorn as it stood right then and there, but Longhorn has changed quite a bit since September. Lots and lots of work has been done against it. For those who don't know, Longhorn is our distributive lock mechanism system. And then project and namespaces. So namespace is a Kubernetes concept. Project is our own API implemented as a custom resource definition. There's a grouping mechanism for namespaces. So I can create my own projects. I could have project per dev team. I could have project per application. I could split projects any way that I want. Project per customer in a multi-tenant situation. And then when I do that, I can create, who my members are of the project, which pod security policies get created, my default resource limits for all my namespaces that get created. So I'm going to recommend to you, create insanely low defaults so that your application developers have to provide YAML that says what resources they need. That way you can enforce quotas against them. And so the low defaults mean they have to give you what they want versus, you just default this to all kinds of zeros or 1. And then they actually have to tell you what resources they need so that you can enforce quota limits properly. You might ask, why would pod count or services, be things that I have to quota? Well, remember, each one of those has its own IP address, and subnets have finite amounts of IP addresses, especially if you're out on AWS, VPCs. So something else you have to protect and keep in mind. Members works this way everywhere else, whether it's LDAP or SAML or GitHub. And then tools. So we already talked about monitoring. We've already turned it on. Alerts. So we're using Prometheus Alert Manager to send alerts to various notifiers. So let's say a good one is etcd is unavailable. If etcd is not available, bad things happen. etcd is just a system service called etcd. That's the simplest type of alert that we have. They get more complicated. Like, let's grab high CPU load is a pretty good one, because that's metric-based. So this one is now metric-based. We're looking for, this is a PromQL queries. PromQL is Prometheus query language. So, and it's looking at, for a specific node, look at the count, the count of CPU by instance times 100 to get the percentage. And if it goes above 100% for a 3-minute period, bad things happen. But you can see here, we're using almost no load here, which is really, really nice. We can also look at other metrics like etcd having no leaders. Oh, there's a high number of leader change. That's a good one, because remember, etcd runs in a quorum. It has one master and many listeners, and so we can actually see if the leader is changing. So that's something Prometheus tracks, and we can grab everything over the last hour. And if we have more than 3 in 3 minutes, there is something bad going on at etcd, because etcd should not be switching leaders that often. Suggests a network problem or a resource problem on the etcd servers. But you can see here we have 0. And 0 is what we should always have. I would probably mark that to 1. I want to alert when it goes to 1. But once that goes off, we attach alert to a notifier. And a notifier also uses Prometheus Alert Manager to talk to the Slack or email or PagerDuty or WeChat or anything that understands webhook, which should be everything at this point in time. If your notification system doesn't understand webhook, go buy a new one. Next are tools. Is catalogs. We talked about this earlier. We have our library of catalogs that are our Rancher charts that we maintain. What's our system library of all the things that are important, for Rancher. But we can also add your own. You can add them at the global level, the project level, or the cluster level. So you can have different sets of Helm charts. And there are specifics about what Helm charts look like and how they're run. At Chart Museum, you can run your own and find lots of information about running Helm charts in various environments. I could even turn on catalogs for, I don't want a custom one. If I would go to my global level and go to, not cluster, tools, catalogs, I can turn on the Helm stable and Helm incubator. And these are community curated. So we have no ability to speak to the quality of these things. These are the ones that we maintain that have same defaults for some of these, and some stuff ripped out that we think is just too complicated and you don't need most of the time. So going from the cluster level, next step is logging. We'll set up Fluentd to send logs out to one of these systems. At the cluster level, this is a fire hose. It will send everything from standard out and standard error and forward along. So if you're using this, and I love Splunk. Splunk is also a system, but you pay for Splunk by indexed gigabyte per month. So unless you're the government and have unlimited Splunk, the government has unlimited Splunk oftentimes, unless you're the government or have lots and lots of money to burn, don't turn this on at the cluster level. Do it at the project level with these things that you want, or send it to Fluentd to spread out, or send the syslog to spread out. That way you're not blowing out your Splunk license in like 12 hours. We had an open source user who had some money to burn and wanted to test just how much Splunk he could spend in a week. And he spent 30 grand in a week on a very big Kubernetes deployment. But they need to know just how big it would get, how quickly. So we've run all the way through cluster level. Matthew, what questions do we have before we dive into project?
Let's see. There's more sort of creating cluster questions.
Okay.
Do you want to take those?
Yeah, we'll take a couple of those.
Okay, great. This is from Vin. When creating a downstream cluster using Rancher, do any special accommodations need to be made to perform this offline, air-gapped, or sandboxed?
So definitely check out the air-gapped installation instructions, docs.rancher.com. Then 2x installation, and each one of these has special items for air-gapped. For all the requirements, for port requirements, check out this. For node requirements, check out this. So as far as versions of things that you'll need, what kind of hardware you'll want, networking requirements, and as far as our ports go as well. And there's a whole other page just on the port requirements themselves. Next question.
Cool. Quite a few questions on AWS. Here's the first one. This is from Hamad, who says, it's kind of a troubleshooting question. He says, I installed Rancher and added nodes from AWS. Later, I decided to assign Elastic IP address for the Rancher server, and as a result, I lost connectivity with the cluster and eventually had to rebuild it from scratch. I may need to scale up my Rancher nodes at some point, which requires restarting EC2, but I'm concerned I might lose connectivity with the cluster. Is there any special configuration I have to set before switching to an Elastic IP or restarting EC2?
Yeah, use static IPs. Don't go messing around with dynamic IPs, because there are all kinds of things internally about Kubernetes that need to know where they're calling. Don't mess with IPs to change. Everything should be internally static IP if you're on a private, and used to be a private IP now. Private IP static. Anything public you could do Elastic, but then it just means you're handling load balancers that are going to public IP addresses and worker nodes, and you're doing all kinds of routing and fun stuff that you don't really want to get into. So I recommend static IP addresses as much as possible.
Awesome, thank you. Okay, here's the next one. This is actually from Hamad again. He says, I enabled monitoring on the cluster and project levels, and also added and successfully tested an email notifier. However, when I configured alert rules, none is sent. Any idea why that's happening?
Now you have to look at your logs. But the notifiers don't go off right away. They take the alert takes, there's a grace period in there. I don't remember what it is exactly off the top of my head, but in my own testing, I found that the difference between how often the alerts get checked, then noticed, then the notification is sent out, and a lot of that's just to prevent spamming of the notification systems. There's some timers in there. So it may just be having a timer, or the issue resolved itself before the notification went out, things of that nature. Okay. But check your logs.
Cool. All right, here's the next one. This is from Alec, who says, in an air-gapped HA setup, is it best for every node to have all 3 roles? And how do you make sure that each plane in each node uses the private registry to pull the images?
So the configuration of private registries here in the documentation, I would recommend against giving all 3 roles to your nodes. I would have a subset of nodes that their only job is to be control plane, subset of nodes for etcd, and a subset of nodes for workers. Or if you're more comfortable or you're resource constrained, control plane and etcd are on the same node, and then workers are separate, because you don't want your worker nodes eating so much resource, or you don't want your workloads eating so much resources that Kubernetes can't be Kubernetes. So you want to separate out your worker nodes from your control plane.
Cool. Okay, thank you. All right, here's the next one. This is from Mirko. What is the suggested AMI to use to deploy a cluster in AWS? And what are the recommended settings to put in the node template for AWS? Do you maybe have a
I believe we have a documentation on some of that around provisioning Kubernetes clusters specific to the Kubernetes providers, and on the different cluster types. So yeah, go through your docs specifically around EKS and around where is that? It's under custom cluster. It's around not hosted. It's Rancher launch Kubernetes and infrastructure provider and EC2. We have information about EC2 specific here. So yeah, do read through that doc. See any more questions. Lots of people out on the Slack channels who are ready to help, who know a lot more about EC2 than I do.
Okay, cool. Thanks for your humility, Jason. All right, this is the next one. Here's from Renee, who says, what user does Rancher use to perform commands on AWS resources like EC2 when installing clusters or pulling Rancher system Docker images?
It's gonna depend on how you set up when you set up your node templates, and when you set up your. It's all laid out here as far as IAM policies and all that goes.
Okay.
So it's whatever you give it.
Okay, cool. Flexible.
And your problem is likely a security group. It's almost always a security group. When you have problems, it's going to be security group related. Every issue I have on AWS, runs down to an IAM policy that is not set up properly.
All right. Okay, here's the next one. This is from Sergio, who says, as an alternative to a full air-gap install, is it possible to use a proxy to fetch the external resources?
Yes, you can set a proxy. It's in the advanced options or installation. You go to installation, you go to the advanced options. There's all kinds of stuff under proxies there.
Sweet. Okay, cool. That was the last question that I see. So if I missed your question, everybody, please ask it again, or ask more. Anything else you want to show us, Jason?
Yeah, let's drop down to project now. So we did our global level, which is Rancher and all its Ranchery goodness. We did cluster level, which is an individual cluster. And now let's drop down to project level. And projects, remember, this is our grouping mechanism for namespaces where our workloads live. So by default, we take the default namespace in Kubernetes and put it in the default project. And we take all of the kube system, kube public, and anything cattle system, rancher system related in the system project. So I go to this project here. We even warn you, hey, don't muck around. Oh, that's not good. Network failed request. So we even tell you, don't muck around in here. bad things will happen if we muck around in here. All of a sudden, this got slow. Let me check to make sure this thing is still alive. Docker PS. Nope, still up and running. Docker. Oh, I know what happened. The Docker container just restarted. Something happened on my machine. The Docker container restarted, and it went down for a minute because my Docker status is up 23 seconds. So just like that, my Docker restarted, and everything looks just fine. So going back to system project. Yeah, don't muck around in here is what it says. But we can still look at it. We can see all the things that are here, like our Grafana, our Prometheus. Everything has a cattle system, which allows us to do our communications. We have our ingress controller here, and all the standard Kubernetes things, like Core DNS, like metric server, like our ingress deployments and things like that nature. These deployed jobs should already be done because they were just jobs, right? Yeah, deployed jobs succeeded. So here, these various jobs. So job are one of the deployment types of Kubernetes, and it really is run once and be done. So these things ran and are done, but we still have the metadata about what they did when they were running. Like where is the Core DNS deployed job? And we can see here that its job was due. Actually, I have no idea. We can see that it did its thing. It was created. It ran whatever it needed to run. Complete once, then be done. What command did it run? Can we see that? Oh, yeah. Yeah, kubectl apply. So essentially, it was running another Kubernetes command to deploy Core DNS. And then we can see here, Core DNS is up and running, I bet. Yeah, Core DNS up and running, like we'd expect. So let's grab our default project, because we don't want to muck around in system. Bad things will happen. All right, checking to see if this thing is, it's still happy. It's just being slow. Wondering if one of the kids are messing around with the internet here in the house. Yeah, network request error. Please tell me it didn't restart again. Yep, it restarted. Yeah, something's going on my other machine that is running this demo from it. 1 second, I'm going to check top on this thing and see what it's doing. Yeah, everything looks normal, at least for now. I'm going to leave top up in my background just to watch it to see if something is destroying my machine in the background and causing Rancher to restart. Yeah, okay. Rancher's behaving. We'll let Rancher keep behaving. Going down to the project level. All right. Appears my system is not happy. Yeah, my Docker keeps restarting. You know what? We're going to Docker stop and Docker restart this thing. Something's going on my own machine. Docker stop. And Docker start. Docker start. All right, and Docker, we're going to attach to this to see what's going on. Docker attach. And we'll throw up stop here, and everything looks to be restarting. I'm just going to watch it while it's running just to see if we've really hosed up some things. All right, everything looks to be working right now. Let's take a look at that. Let's go back and see if our projects are working. We're back up. All right. So now we can see our workloads running. We have our Redis multi-cluster that we launched earlier running just fine with our single pod running. Let's launch something else, because I want to show off what APIs we're talking to right now. So we have our Nginx. Let's create an Nginx container. And here we have our pod spec. We'll grab our Nginx container. And we can actually change our our replica set here. We'll have 2. We can use any namespace in the project. I'm just going to use default. I can create my L4 service here now. Remember, I don't have a cloud controller manager, so I shouldn't be able to create the load balancers. Oh, it should have detected that for me. So then I'll check into. Oh, because I flipped it back and forth. I wonder if I got confused. I'll check into that. So we can also create environment variables, both from secrets and config maps, as well as by hand. So let's just grab a secret. I don't know how many ones. Config maps in here? No config maps. Let's create one real quick. So I'm just going to duplicate this. My Docker is just completely hosed again. And start it right back up. So that 404 you saw was actually the ingress. The ingress controller was still up. Just Rancher had gone bad, so it couldn't go to the container.
Hey, Jason, someone asked,
Yeah.
Sergio asked, related to what's happening is, he says, could these restarts be happening because monitoring was enabled on a resource-constrained Rancher cluster?
No, so the actual cluster is out on DigitalOcean. I'm running a single node install, but I'm having some pretty serious failures coming from. I'm watching localhost on 6443 failing on my own machine, and I think honestly, my machine just needs a restart. So if this continues to happen, we'll stop the demo for today, and we'll pick this up next week. So again, let's try to run Nginx. Port 80. Yeah, I'm watching my machine start to freak out over here, and I have no idea why. So I'm guessing there's something wrong with my machine. But let's see if we can get this thing to go before we go. So I'm going to give it a, let's set this up. We'll go through each one of these and what they do. So this is our pod spec, our replication controller, our service. We can set up config maps and secrets. That's what I was doing over here. And here I actually want to create a config map for testing. Oh, we have one here. We'll say my map. Key 1, value 1. And we'll save that. And we'll use it over here. So environment variables, I can hand create my own. Key by hand, value by hand. I can also set them up from config maps and secrets. I can do node scheduling. So my nodes have labels on them. So if I take this over here and I go over to my nodes, I can see here that each of my nodes not just has names associated, what their roles are. If I go to each individual node, yeah, I think my Rancher container is restarting again. Funny thing is, it's actually pretty robust for whatever's wrong with my system. It's just restarting and going back to where it was when it restarted. So if we go back to our node here, we can see the actual labels on this node. So we can actually schedule things on this node based on information in the labels. So if I wanted to make sure something was scheduled here, I could set it based on its Kubernetes host name. I could also add in arbitrary metadata here. So if I had a geographic location, so if I were out on the cloud, each one of the cloud providers will actually put what region it's in, for example. So I can target specific regions to do multi-region targeting and all kinds of really cool stuff around node affinity and anti-affinity. Health checks. So there are health checks and there are readiness checks and there are liveness checks. Readiness or liveness check tells the Kubernetes scheduler, hey, I'm alive, don't reschedule me. If you hit none, the scheduler will just figure it's alive until it's not. And the readiness check is I'm ready for traffic. Now, in microservices, this tend to be one and the same. in a non-microservice scenario, like let's say you're taking your Java monolith over and your JRE has to start up and grab a whole bunch of stuff, and you've got some Spring going on, so dynamic class loader things are going on. So that takes a while to start up. And then your application starts up, so your class file gets loaded and all kinds of other stuff. So the difference between I'm alive and I'm ready could be a couple of seconds, and that's important to the scheduler to make sure you're actually alive. Volumes, like I said, not going into storage today, but we can create ephemeral volumes for in-memory stuff so that the volume lasts beyond the container's death. So containerized, we still have our stuff in the node's memory, in this case 30 megabytes. We used to call these megabytes back in the day, but it's that whole 1024 versus 1000. And then we can also grab, you know what? Let me show you why pod security policies are important. I'm going to bind mount. And I'm going to go onto the host and grab Etsy. And inside of my container, I'm going to call it Etsy on host. And then even my config maps and secrets can be filed in my system. And then my deployment API, I can set how that works here. Let's launch that. We'll let those two replicas come up. We'll watch them come up. We'll see how we can even watch how they're doing. But they came up so fast. And as soon as they start up, I also get pod level metrics from them. Now, that's not enough because we just started them up. We go to Nginx to see, we should be able to see endpoints too. So it's listening on 3,000 or 30,000. So both of my worker nodes are listening on the same port. And I can see I can hit this here. But if I go into my other node, let's just look at my other node and grab, let's see which one I was hitting. I was hitting 68,000, but I could also hit this one too at 30,000. It's interesting, grab 30,000 exactly. And you can see it's listening for Nginx too. So it's routing to one of those two. If I go into each individual pod, I can see the pod running. I can see pod level metrics. I can jump into its Grafana. I should have a little bit of network I/O in here because we just kept hitting it. Nope, no data points yet. Can we do last minute? No, there's no last minute. That's too bad. But we will have, can we do, here we go. Yeah, no, still no data. Yeah, it's going, yeah, that's too small. I can't handle that. I have no data to look at. But this pod specifically, we can just look inside here as well. We can see the logs. Oh, this one hasn't had any data. Interesting, the round robin, or it's not even round robin. It's non-deterministic for as far as which one it sends data to. And let's see if we can get some data out of this other one. So that's its 10 dot address. Which one? Oh yeah, I can't see. I don't know which one it's running on. Do we have logs here? Nope, none there. This one is just not getting data yet. Oh, I'm getting a cluster unavailable. That's what's going on. I'm guessing what happened is my container restarted again while I'm doing all this. Yep, that's exactly what happened. All right, we'll log back in. The fun of live demoing. Yeah, I usually set up a prod system separate from my own machine, but my scripts failed. And I think it's probably where we've used too many resources. Cluster unavailable. There it goes. Now it's back available. It's actually it's fairly fault tolerant. Whatever's going with my own Rancher is driving me crazy, but you'll notice that it's actually handling the faults pretty well within a couple of seconds. Yeah, we can see our logs actually running on the system. And if I just keep hitting reload, I should be getting more live logs. Eventually, it'll hit this system. Again, it's not round robin. It's kind of a non-deterministic thing. I forget exactly. I think it's random by default. And then, in addition to being able to see the logs, we can also shell into the system if the WebSocket is up and running. All right, come on. So you actually want to protect in your RBAC exec. Exec is a separate sub API to protect as well. So let's execute shell. And once the Rancher agent comes back up, We should go shell back in. There we go, we're back in. So the reason that you have to have pod security policies is so you can't do this. And I'm now looking at the host itself. I can see my in-memory stuff, and this is ephemeral, but I can store stuff here that will survive container death. And then I actually have my config map here. I got config maps. Each key is set as a file. And you can see here there's the value one over there. There's no enter at the end of it. And then if I want to look at my environment variables, you can see here I have the one for the key that I entered by hand and the key that is part of that same config map. And you can do the secrets as well, which is really useful for certs at runtime. We can also create layer 7 ingress rules. And it's restarting again. This is running against my, this is actually redirecting to my Linux laptop sitting right here, right next to me. And top is going crazy now. So I've got something in the background that is just eating my machine alive and misbehaving. And it's affecting my demo environment. But we can actually create an ingress. And the zip.io is poor man's class A DNS. So I'm going to create one for this Nginx here. This is kind of like let's encrypt for class A DNS. Now I can select the workload, but I already have a service. I'm going to take advantage of the service I've already created. Go to slash, and then a couple things will happen. Waiting for cluster age to connect. Yep. So I'm restarting again, apparently. There we go. So we see here zip.io has already created a DNS, and zip.io is sending an IP address. And as long as we hit that IP address, we'll get that IP address back from the class A query. So let's go ahead and try to hit that, and we can see here we can hit Nginx. But let's change to something that the ingress rule doesn't cover. And you can see by default it creates an ingress rule with the name of the ingress, the name of the namespace it's in, the public IP address, and the zip.io. And that should be going into the backend service, which it is. But if I change this slightly, this will actually resolve the same class A from zip.io, but now I'm getting a 404. You can see that because of the ingress rule. So if we want to look at the ingress rule, we go into the cluster itself, go into kubectl, and describe all the ingresses. And we can see here, the ingress is specific to this host name. So as long as it comes into this host, on the blank path, it will go to the Nginx node port service on port 80. So if I want to look at that service, and we can see here, the way services route is based on labels and selectors. So each one of those pods, where's the selector? I'm looking for annotation, describe ingress, so it's my ingress, describe service. My service is looking for, where's my selector? There's my selector, is looking for labels that look like this. So if I look at my pods now, every pod that has this label on it will get routed to from this service. If I go kubectl, oh, it looks like I lost my system again. Let's give it a second. Yep. Unavailable. We'll wait a second for it to reconnect, and I'll show you the pods themselves. So I go to kubectl now. I do kubectl, and let's get my pods. I'm just going to select one of them. You can see actually I have two of them. So if I do a describe on a pod, and it'll actually grab the description of both of them, but you'll see they both have the same label here that match the selector on the service. So you might ask, well, what if I have one of these misbehaving? I don't want them to be part of what my client sees, but I still want to figure out what might be going on there. Excuse me, because I can exec into them. I can actually remove the label from them. So let's go into one of these pods and remove its label. So if I go into default here, and we'll go into our workload. Oh, you see here now we also have our layer 7 ingress. But let's say this pod is behaving badly, and we no longer want it to be part of the replica set, and we no longer want it to be part of the. I thought I could remove that from here. You know what? I've forgotten this kubectl command off the top of my head. Oh yeah, I know how to do it. I just edit the pod. Duh. All right. Going back into kubectl real quick. kubectl. Well, we're gonna wait for Rancher to restart on my machine. Oh, never mind. It was just being slow. Nope, it's gone. All right. Come on back. Be available. So what's happening is my local Rancher server is restarting, but the Rancher agents on the cluster is working just fine. So as soon as Rancher restarts, it just logs back out. The clusters phone back home into Rancher. This would be a lot like if a Rancher server goes down and you need to recreate one. It'd be a good DR scenario. I have no idea why it's misbehaving this badly on my computer, but it is. But if we want to edit one of those pods, we have command line completion. We're just going to grab one of them, and I'm going to grab this one. GC X. All right, I'm just going to copy this. I think my cluster agent has gone back down. Yeah. Come on. Yeah. Yeah, my memory utilization of this local machine is spiking for no apparent reason. At least nothing that I can see straight from top. But Docker is just restarting it back in to CTL edit pod. Oh. We'll edit that, and we'll actually we'll remove the labels right off of it. So that pod has now been edited, and we'll actually, if we go back into our workloads, we'll actually see essentially an orphan pod. So as quickly as that happened, the replica set went and created a new one for me. So the service will no longer hit this pod. This pod is essentially orphaned from the service and from the replica set because we removed its label. So we still have the available one, but if we want to go in here and see what's wrong with it, I could actually exec into this pod and see what's going on inside the pod separately from what my users are seeing. So all that to say, your labels is your selectors. Your label is your only grouping mechanism in Kubernetes. Your selector is how we query against those labels for the purposes of replica sets and services. So we can see here the service has this node port service. We can see here the node port talks to the Nginx workload. But because I ripped that selector off, this specific pod is no longer part of this workload. And I think I'm going to stop there because I had enough restarts, and we've gone through most of Rancher today. If you want the CLI, you can download it here. If you'd like a quick, dirty training on the CLI, I've done one in Katacoda, which is live coding. You go to Katacoda/Jason Van Brackle. I've done a number of lessons in Katacoda. I'll be doing more, but I have it almost done, but not quite done CLI course. When the CLI course is actually done, I'll advertise it on our blog post. I'll probably talk about it in the Ranchcast. But if you want to see the preview of it, you can see it there. I'll walk through how our CLI works, setting up your API keys and all of that. So, Matthew, what other questions can I answer? Because I'm sure I'll have some other problems with this Rancher server, but we'll do our best.
Right. No problem. There actually are not any new questions. So, yeah, I think we're good, unless there's anything else you want to show us, and I have some closing slides.
Yeah, well, I will thank you all for tolerating whatever has gone on with my machine in the last 20 minutes. But if you want to learn more, by all means, read the docs. We spend a lot of time making sure that our docs are great. It's rancher.com/docs. Do join our Slack community. That is slack.rancher.io. I am JVB out there. So it's at Juliet Victor Bravo. feel free to say hi. I'm not always available for like, live QA and support, but we have lots of channels of people who are and who do. I will, if you do add JVV me, I'll check it out when I'm live on the Slack. I'm always on Slack technically because my phone is always on, but just doesn't mean always being available. But do ask questions. If I don't know the answer, I will find somebody who does. I'm a former field engineer and operator and software developer, so feel free to ask me technical questions, not just about how to run Kubernetes, but even how to build applications around Kubernetes, because it's one of those things I do on the side. Again, you can find me on Twitter. I'm also on LinkedIn and all those things. If you do find me on LinkedIn, just say, hey, I saw the Slack demo. Can you add me? Because I do tend to ignore recruiters and things of the like. But community members are more than happy to connect with me and share life with me in general. So thank you all for your time today, for tolerating weird glitches, and happy learning.
Fantastic. Thank you so much, Jason. Okay, I'm going to just show a couple more slides for everyone in case they missed these and want to do some additional training. As I mentioned before, we have a lot of different classes. So every Tuesday, we have these free courses on different topics of Kubernetes. Next week is Storage OS is coming in and going to talk about database recovery. And then in 2 weeks, Jason will be doing another class on alerting and visualization. So that should be really cool. Dive deeper into Prometheus and Grafana. And then later in August, we'll talk more about just disaster recovery. So lots of cool stuff to check out. And all of these presentations and trainings are on our website, all the past ones, so you can download those and get the slides and go through those as well. Thank you all so much for tolerating those glitches, as Jason said, but also providing your questions and providing your feedback in the survey. Everything we do here is live, so we try to just make this as real as possible. And if you want to give us a shout out on Twitter, just let us know with the hashtag Rancher K8. Let us know how this training went for you. And if you have further questions, we'll see you on Slack. Thanks, everybody. Have a great rest of your week. And Jason, awesome job. Thanks so much.
Thank you.